Okay, so that previous video was actually discontinued because there were the method which I told you about, to find the direction of magnetic field will actually not be valid over here. Why? Because this case is neither a part of this one or this one. It is actually a simple current element in which there is no direction. Actually, there is no direction. So for this we have this formula, right? dB is equal to mu naught by 4 pi IDL cross R by R cube. The direction of DL cross R will give the direction of dB for this position. So for a cross product we should know how to find out the direction. So say DL is outwards, right? Actually it is outwards. It is shown like this because it is in a 2D plane, so it cannot be shown like this, but actually DL is outwards. So DL is outwards and R is like this. So DL is outwards and R like this, right? DL is like this, ऊपर की तरफ. You should learn this. Like how am I doing? DL, जिस direction में भी the first term is there, of the cross product, put your palm in that direction. Like DL ऊपर की तरफ है, put your palm ऊपर की तरफ. You could also have put it like this, but why did we not put it like this? Because the second term is इस तरफ. It is not इस तरफ, it is इस तरफ. So we face the palm in the direction of the second term, but actually we put the hand in the direction of the first term. So DL is the first term, so we put the hand in its direction, DL, and now we chose this orientation and not this orientation because R is on this side. So now fold it towards R and you will find out the direction. So this is the direction. R was like this, it was not like this. R was like this. Why I am saying R is like this? Because R is like this. It was not like this, it was like this. So it was up and then it got folded like this. It will give this direction. So this is the direction of dB. Okay, this is the direction of dB. Now this dB will have two components, one along the x axis and one along the y axis, and if we take this angle to be theta, then this angle will be 90 minus theta, this angle will be theta. So dBx along the x axis, the net resultant component will be dB cos theta, which will be equal to mu naught by 4 pi IDL times x square, IDL by x square plus r square. Till here dB we copied, dB was copied till here. यहाँ पर this is dB, this thing entire is dB, which is this, and उसके बाद we'll find out the value of cos theta. Now what is cos theta in this triangle? This angle is theta, so this angle is 90 minus theta. If we try to find out cos theta, so cos theta you will see that it will give us the value r by root under x square plus r square. You can find out this angle is 90 minus theta, find out the value of cos theta in this triangle. So cos theta will give us r by root under x square plus r square. This thing entire multiplied x square plus r square to the power half and x square plus r square to the power 1 will give us x square plus r square to the power 3 by 2, and this formula will become dBx along the x direction mu naught IDL r by 4 pi x square plus r square to the power 3 by 2. dBy will get cancelled. Why? Because there will be a point over here also which will have the magnetic field in this direction symmetrically. So it will also have a dB component in this direction, a dBx component in this direction. dBx component gets added up and dBy component will cancel each other for each of the elements we will consider. So dBy gets cancelled. Now B net, the net magnetic field over here will be the integration of dBx. It will be equal to mu naught by 4 pi IDL r by x square plus r square to the power 3 by 2 का integration. So all these things are constant other than DL. DL is not a constant, so DL we will integrate, and if we see the DL which we have taken, this GL, if this is integrated, this is a small current element along in this circular current carrying loop. So if this is integrated, this will give the entire current carrying loop, and the entire current carrying loop will have a length of 2 pi capital R, where R is the radius. So mu naught by 4 pi I r by x square plus r square to the power 3 by 2 into integration of dl will give us 2 pi r this formula entire will turn into this r. R gets multiplied, r square, 2 pi, 4 pi, 2 will be over here left, and this thing changes to mu naught I r square by 2 times x square plus r square to the power 3 by 2 I cap along this direction. Now if we are asked to find out the value of the magnetic field at the center of a circular current carrying loop, so all we need to do is we need to make this distance x equal to 0, so that it comes over here, that point comes over here, and so what we will do is that x will put it to be 0. So when x is put 0, b net will change to mu naught I by put x equal to 0 over here, this thing will change to mu naught I r square by 2 times r square to the power 3 by 2, which will change to mu naught I by 2 r I cap. You can put x equal to 0 and then check.